Hello, in this problem, we're going to calculate something called the real interest rate. And so we've got a situation where the bank is charging a person 6% to use money for something. It's a loan. We don't know what the loan is about, but that's okay. It doesn't matter. And so that is the nominal interest rate. Okay. So it's the current present period price of that loan. Okay. Then what we know is that inflation eats away at the value of money. It makes money cheaper. So this is going to change the real value of the money that has been borrowed. So for that, we're going to use something called the Fisher equation. Fisher equation can be used in a lot of different ways. In this monetary context, we're going to use it as real oops, interest rate equals the nominal interest rate minus the expected inflation. Okay. So in this particular problem, we've got the nominal interest rate is 6, the inflation rate is 5. So effectively, or the real interest rate is 1%. That's what this person is going to pay um, in real terms, we say. Okay. Now, a sort of a deeper question that goes with this is if the expected rate was 5%, but the actual rate was only 3%, we want to recalculate that real interest rate. So in that case, the nominal rate isn't going to change. The inflation rate is only 3%. And so now we have a 3% real interest rate, which is higher for the lender. So the lender would be worse off in that scenario. I'm sorry, the borrower would be worse off in that scenario, and the lender would be better off in that situation. Okay. Now, if actual inflation is higher, so let's say that actual inflation is not 3%, but it's 10%, that nominal rate, as long as it's a fixed rate, isn't going to change. So then we actually have a negative 4%, which means the lender is worse off. So that's kind of a rule that you can remember is that with unexpected inflation, the lenders are worse off and the borrowers are better off.